So we finished reviewing Pythagorean theorem and special right triangles, and now it's time for right triangle trigonometry. So we're going to use sine, cosine, and tangent, and remember the word SohCahToa. Okay, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So here's our angle for our first one. And over here is the opposite leg, and here is the hypotenuse. Opposite leg and hypotenuse is here under sine. So we're doing sine 31 degrees is to 1, as the opposite is to the hypotenuse. Okay, now when we have a number here in the denominator, we just multiply it across. So we get x equals 18 sine 31 degrees. Okay, so 18 sine 31 is 9.27. Now it says the nearest tenth, so that would be 9.3. X equals 9.3. Our next triangle, we have here the adjacent leg and the hypotenuse. Adjacent and hypotenuse is under cosine. So we have cosine 65 degrees is to 1, as the adjacent leg is to the hypotenuse. And once again, we have a number in the denominator, so we multiply it across. So x is 12 times cosine 65 degrees. So 12 cosine 65 is 5.07, so 5.1. And here we have the adjacent leg, and we have the opposite leg. The opposite leg and the adjacent leg come under tangent. So we have tangent 55 degrees is to 1, as the opposite leg is to the adjacent leg. 20 is to x. Now this time we have a variable in the denominator, so we treat it differently. We solve it by switching diagonally. So we get x is to 1, or just x is 20 over tangent 55 degrees. So 20 divided by tangent 55 is 14.00. So x is 14.0. Okay, find the measure of each angle rounding to the nearest tenth. Okay, so let's start this one with angle P. Okay, so we have the opposite leg and the adjacent leg, and that is tangent. So tangent P equals the opposite leg over the adjacent leg. Anytime the variable is the angle, we do an inverse. So P is the inverse tangent, 18 over 11. So second tangent, 18 divided by 11. 58.57, so 58.6 degrees. So the measure of angle P is 58.6 degrees. Okay, now we can easily get that last angle, N, by doing 180 minus 90 minus 58.6. Okay, now 180 minus 90 is 90, so we can take a shortcut here and just do 90 minus 58.6, and we get 31.4 degrees. So 31.4 degrees is the measure of angle N. Okay, so here let's start with angle U. So across the triangle we have the opposite leg, and the 23 is the hypotenuse. Opposite and hypotenuse, that's going to be sine. So we have sine U is equal to the opposite leg over the hypotenuse, 23. Okay, so U is inverse sine. Sine inverse 7 over 23. So second sine 7 divided by 23. So the measure of angle U is 17.7 degrees. Okay, so now we can do 90 minus 17.7, and we get 72.3. So 72.3 is the measure of angle S. So on our next triangle, let's start with angle E. So we have the adjacent leg and the hypotenuse. Adjacent and hypotenuse is under cosine. So we're going to use cosine this time. Cosine E is equal to the adjacent leg over the hypotenuse. So E is equal to the inverse cosine, 19 over 28. So second cosine, 19 divided by 28. So we get 47.3. So the measure of angle E is 47.3 degrees. Okay, then we can do 90 minus 47.3 to get angle U. So 90 minus 47.3 is 42.7 degrees. That is the measure of angle U. For our last question, if an airplane is required to fly at least 1,000 feet above any obstruction, what is the minimum altitude at which a plane could fly as it passes over this building? So as a plane passes over this building, it has to be at least 1,000 feet above it. Okay, so what's the minimum altitude? So it's going to be 1,000 feet plus whatever we get here for the height of this building. So our angle here is 25. Over here we have the opposite leg, and right here we have the adjacent leg. That's going to be tangent, opposite leg and adjacent leg. So tangent, 25 degrees, is to 1, as the opposite leg, x, is to the adjacent leg, 250. Okay, so here we have a number in the denominator. We are going to multiply that across. So we get x is 250 times tangent 25 degrees. So 250 tangent 25 is 116.57. That is the height of the building. The airplane has to be at least 1,000 feet above that, so I will add 1,000 feet. So that's 1,116.57 feet for the minimum altitude of this airplane in order to be following FAA regulations.